Right friends, I have another video for you on spanning tree here, and today we are going to discuss about per VLAN spanning tree. I have two switches. This is the topology that I'm going to use, and we have two switches, no VLANs created. I'll just show you the basic config. Show VLAN, and we have just VLAN 1 and default VLANs being there. We just want to see if any kind of spanning tree is running. For VLAN 1, the spanning tree is running. I have two interfaces connected between both the switches here. Both the switches, I have two. This is switch 1, it's switch 1 and switch 2 here. And we are running the per VLAN spanning tree here. So we can see that we are the root here. Switch 1 is the root. Now root is elected based on an election process. Election process will have something called a bridge ID. Bridge ID is a combination of priority value as well as the MAC address. So first it will try to compare based on the priority. If the priorities are same, which by default on two new switches, if you did not configure anything, is going to be same. The second parameter that comes after that is MAC address. So if the priorities are same, the lowest MAC address wins. So either the lowest priority or the lowest MAC address is going to win. The default priority that you have is 32.768.68, right? But it becomes an extended priority because of adding the VLAN number here, right? That's called extended VLAN ID basically, and it becomes by adding the VLAN number. So if I have VLAN, let's say 2, it's going to become it will be 2 added at 68, so that should be 770. Let's do that. I'll create VLAN 2 here, and we'll see show VLAN. Now I turned on the debugs actually just to see what kind of port state it goes through. So I have this, and I'm going to be show spanning tree VLAN 2 is what we want to see. So you look at it here, we have 770 as the priority. Why? Because the default is 32.768 plus the VLAN number 2. So that's how your extended system VLAN ID will be created. Very important to create a unique ID. You add the system ID plus the VLAN number here. Right? Now you see that I have turned on a small debugging here, so we can see that it was showing us when it was coming up here listening. Right? You see that listening here for this new VLAN, and then for VLAN 2 it's listening, and then you are learning here. If you missed out on that, I'm going to turn on another VLAN here, and we will see what happens when I have created a new VLAN. So now it's creating a spanning tree instance. It's initiating the spanning tree instance here, and we have VLAN 3 is going into listening stage. We'll see what happens after this. Alright, so on this side, if I see I have 3 VLANs, show VLAN, and if I do show spanning tree also, I am seeing 3 instances of spanning tree. Show spanning tree, I see spanning tree running for VLAN 1, VLAN 2 and VLAN 3. But we have to see now by going to second switch, how many spanning trees do we have? Only one spanning tree for VLAN 1. And how many VLANs do we have? We have only one VLAN. Right, so even if there is no VLAN exist on the other side, spanning tree is very local. If you have minimum one interface active into that VLAN, or if you have a trunk port up which has that VLAN which allows that VLAN, in that case the spanning tree is going to be active even if the VLAN doesn't exist on the other side. So here I have right now VLAN 1, 2 and 3. 1 is by default, so I have spanning tree running for all that, but by default right now I have only 1. I'm going to create 2 and 3 here. So VLAN 2 and VLAN 3 is what we are creating here, and now I can see show spanning tree VLAN 2. So what's happening here is it's going into listening, right? Going into listening. Then we go back to, I think it should be now, by then it will be in learning. I go back here and we see that it's still learning, and finally if everything is fine, it should go into forwarding. It's in forwarding now, right? Now we see constantly that the gigabit port number 24 is actually blocked, right? Because the election parameter that you have for a root port election, once the root ID is selected, as you see here, we are not the root. We'll go to the other switch to see if it's the root. And we also need to make sure that for VLAN, whatever VLAN number 2 or whatever VLAN we want here, in this case, let's say for VLAN 2, what I really want is, interface. I want one of this gigabit 24 should be the the port which should be in forwarding. I don't want it to be blocked. I want this port to be blocked, right? So I will go interface gigabit 023. There are two ways. Either you reduce the cost of this or increase the cost of the upper one. So I'm going to increase the cost. Spanning tree cost. Now I can also say spanning tree VLAN, and just for VLAN, and I want to say cost. So that's actually is going to only impact VLAN 2, right? If I just say cost, it's going to impact all VLANs. So I'll just say for VLAN 2, I want this port number 24 to be preferred. So I'm going to set a port cost of 30, and then I say show spanning tree VLAN 2. See what happens. This is in forwarding, and this guy is blocked. Right, so between two switches, when this switch is elected as root, right, and the switches have to decide which port has to be root port. A root port is one which leads toward the root, and root port never has the root bridge never has the root ports. It has always the designated forwarding ports, right? So the root port here, how it will be decided, it is decided always based on the lowest number. So 23 was selected by default because the port number was lowest, and that's the reason it was elected, right?